There's a new browser-based game development tool called Pulp that helps people make games for the Playdate with no code. However, if you want to do anything except for the most basic functionality, you'll need to use PulpScript, the scripting language for this new tool. If you're new to game dev and haven't coded a single line before, this is the right video for you. I will go over everything from how PulpScript interacts with the rest of Pulp all the way to programming basics. If you have development experience but haven't used Pulp before, then this video should still be somewhat helpful since Pulp development is very different from other game engines. Welcome to PulpScript, a beginner's guide. A script is just a document that has some code in it. This is the basis for all of PulpScript, so we have to go over this first. What's interesting is that in Pulp, scripts have to belong to what I call a specific owner. Here are the different possible owners. First is the game, the script of which you can access by pressing this button here. There's only one instance of the game, so there's only one script associated with it. Anything that has to do with overarching game logic and game data, you can put here. Next are rooms, which you can access their script by clicking this button here. Each room can have their own script. Next are items. The default functionality is when you walk over an item, it will disappear, display a dialog box, as well as add one to a plural version of the tile name in PulpScript. An example is, say you have an item named key. When you pick that up, some number with the label keys will increase by 1. Don't worry too much about the specifics of that for now, but keep that in mind since the functionality is quite useful. However, you can customize the functionality by clicking on the script button here to instead attach a script to the item. Each item can have its own script. Next are sprites. They're the same as items, but instead, by default, you can't walk over them to pick them up, you can only bump into them. Each sprite can have its own script by, again, clicking the script button. Lastly is the player. The player is similar to the game, where there's only one instance of the player, so the player only has one script, which I'm sure you know by now how you can access it. All scripts can be accessed in the Scripts tab and then under Sources. But if you can't see a script for something, that means you need to go access it first by way of script button press. It's like creating a new document. Now that we know where we can put scripts, how do we actually handle game logic in these scripts? That's where events come in. An event is something that happens in the game, like the game loading, entering a new room, or the player bumping into something. These events are then sent as signals to all the different script owners, like the game, a specific room, or a game tile. Within each script of the different owners, you can then intercept the event signal and decide what to do within a block of PulpScript code called an event handler. On event name, then do something end. For example, let's say you wanted to display a dialog box whenever a player enters a new room. An option is to go to the script that's owned by the game and use the event handler that intercepts the enter event, and then use this command to create a dialog box, which will then look like this. All game logic must happen in response to one of these events, so no writing code outside of the event handlers. What's very important to keep in mind, however, is that not all events are emitted to all owners. For example, the collect event will only be sent to the item that the player picks up. Let me go through some of the more commonly used events. There are more, but you can see all the different event types and their descriptions in the PulpScript documentation, which I've linked in the description below. Load is called once at the very beginning, and it's called on the script of every owner, that being the game, every room, every tile, every sprite, and the player. This is useful for initializing data at the start of the game, like maybe the player should start off with 10 health, which you can do in response to the load event. Enter is called every time a player enters a new room, and is sent to the game, the room you just entered, as well as every tile in the room. And when I refer to tile, I mean all the visible things that exist in the room, like the player, the item, and the sprites. Interact is called on a sprite whenever the player bumps into or acts on it. Collect is called on an item whenever the player steps onto or acts on it. Confirm is called whenever the player presses the A button. Update is called on the player every time the player moves or interacts with something. Draw is called every frame, which I believe is 20 times a second, on the player right before drawing. These are just some of the events available, and as I mentioned before, you can find a list of all of them in the documentation. But I hope you're starting to see how you can use a combination of these events and responses to these events to create your own game logic, like having special items that do something when you pick them up, or moving things around whenever your player moves. An extreme example of this is I used a combination of the draw and update events to simulate gravity and player collisions to create a simple platformer, but that's a very complex use of events. Now that we see how we can handle game logic, how exactly do we implement the game logic? That's where variables, conditionals, and functions come into play. how would you store something like how much health you have, how much gold you own, how strong your attack strength is, or any other game data like that? Well, that's what variables are for. Variables are essentially a way to store data. Let's go back to the health example. Let's say you want the player to start off with 10 health. In the player load event, we can set health equal to 10. This is called initializing a variable. We're setting the variable, in this case health, to the value of 10. Pretty simple, right? Now, whenever you load the game, there will be this variable storing your health. We can't see it right now, so I'm going to use something special called a function to draw this onto a screen. A function is essentially a special command that you can use to do something. In programming, functions take in values, called arguments, and does something with them. Similar to how in math, a function f of x equals 3x plus 5 takes in x, multiplies it by 3, and adds 5. X is the argument in this case. This function is a special one called label that takes in a word or a sentence, which we call a string since it's a string of characters, as well as two numbers, an x and y value representing a position on the screen. It displays the string there. Now, our objective was to display the health, right? PulpScript has a special feature that allows you to embed a variable into a string by means of using curly braces. If we type something like this, it should write the health at the top left of the screen. By the way, the coordinates work like this. The top left is 0, 0, and increases as you go to the bottom right up to 24, 14. In computers and programming, it's standard for things to start at 0 and for screen coordinates to increase down and to the right. As opposed to graphs in math, typically it increases up and to the right. Just something to keep in mind. Anyways, you'll see that it works. And if I change the health value, it reflects to show that too. Now, let's combine events and variables. I'm going to make a health pack sprite that increases your health by 1 whenever you bump into it, and a spike sprite that lowers your health by 1 whenever you bump into it. We can detect a bump with the interact event, and in the script for the health pack, I'm going to write this. The plus equals is a special syntax that means take the variable, add the number to the right of it, and then set the variable to the new result. For programmers out there, all variables are globally scoped. For non-programmers, that means if you set the value of a variable in one script, any other script who accesses that variable will also see the same value. So our player script will see the number change as well. The only other operations you can do are minus equals, times equals, and divide equals, which all works as you expect. For programmers, yes, that means you cannot do assignment like so. It must be done like this. If you just want to increase or decrease by 1, there's a shorthand that exists. Plus plus for increasing by 1 and minus minus for decreasing by 1. Let's replace this with plus plus. Now, if we try in game, we can see that now whenever we bump into the health pack, our health increases by 1. If in the spike code we add health minus minus, then whenever we bump into a spike, our health decreases. Cool, right? However, we run into an issue. Our health can keep increasing forever, and our health can go negative as well. How do we stop that? That's where the very important concept of conditionals comes in. You might have heard this phrase used a lot in the context of programming. If this, then that. That's essentially what conditionals are. You do something if a certain condition is true and don't do it if it's false. Let's see that in action. Let's set a max health value in the player script to 15. Now, in the health pack script, after we increment the health, we should be checking if the health is greater than our max health, right? If so, we should keep the health at the max health. The way to represent that is by writing this. Let's break this down. First, you have if. Then, you put in your condition, followed by a then. Our condition is whether health is greater than max health. If this condition is true, then we do something. That something is setting our health equal to the max health. We then finish off with an end. If health is greater than max health, then health equals max health, end. We can do something similar in the spike script, where we write if health is less than 0, then health is equal to 0. There are a total of 6 ways you can compare different things. Less than and greater than, as we mentioned before, but also greater than or equal to, less than or equal to, not equal to. The exclamation point in programming is frequently the not operator, as well as equal to. In programming, double equals is typically used for testing equality, since the single equals is used for value assignment. If we test this in game, you can see that we no longer go past the max health of 15 or the minimum health of 0. Conditionals can be extended with else if and else, where else if checks another condition after the first if, and else captures anything that isn't any of the other conditions. I'll leave that as an exercise to you to see how that can be used in many different applications. On the last topic of this particular section, let's talk about functions. What if we want something to happen, like the game ending when the player health reaches 0? That's where functions come in. I mentioned functions earlier with the label function, but to expound on that, there are many other functions available for us to use, which are all listed in the documentation. If you can't tell by now, the documentation is very important. I've gotten all the information here about the specifics of PulpScript from the documentation. Let me take you with me on how I would figure out how to do what our original task was. I would go through the documentation and try to find a function that leads to the game ending. I would see that the fin function exists that takes in one argument, which is a string message. I can then go to the spike script and change the condition to less than or equal to, since we should die when our health hits 0. And in the if block, I can add the fin function with my string argument. You can see that the game now finishes when my health hits 0. There are many other useful functions. One of the most useful ones I want to point out is the swap function, which switches out a tile in the game for some other tile that enables some very useful functionality, like a switch that opens a door. There's one last thing I want to touch on, which is a special event variable, which is a little different than the event signals that I covered before. There's some information you can't get with the event signaling system, like the direction the player is trying to move, the angle of the crank, the orientation of the accelerometer in the Playdate, and the coordinates of any specific tile. That's where the event variable comes in. It's a special variable that holds all that data and more. You access that event by using the dot notation. For example, when you're in the script for a tile, event.x and event.y will equal the coordinates of that tile. Let's say you want to make a special pressure plate that teleports you forward. You could create a new item, and in the script of that item, respond to the collect event, which gets called whenever the player steps on an item. You could create a variable called teleportx to equal event.x and teleporty to equal event.y. So now teleportx and teleporty equal the coordinates of the item you're stepping on. You can then increment teleportx by 5, so teleportx is now 5 units to the right of the tile. Then, lastly, you can call the function goTo, which moves the player to a specific location, and use the arguments teleportx and teleporty. You can then use the sound function and pass in the name of a sound effect you made as an argument. And now, whenever you step on this item, you get teleported 5 units to the right with a sound effect, and it works for every teleport tile. This is just one tiny application of the things you can do with the information available to you with the event variable. Keep in mind that the event variable will not have some of its information available in some events. Like in the load event, the event variable will not contain the name of the room you're in. All of these things are described in the documentation. I hope this was a good introduction to set you on the right track. There's a lot I didn't cover, but the key is to read the documentation, experiment a lot, and learn through application. The best way to learn is by trying to figure out something yourself, as you will definitely remember it that way. All the tools are available to you, it's just the implementation that makes the magic. One piece of advice I would give to new programmers is something my first computer science teacher told me on my first day of class, which is that there are many ways out of the maze. The meaning of that is there are many different ways of doing things. A small example is that I could have set the health variable in the game script instead of the player script. There are certainly better ways to do things than others, but technically, there is no correct way since if it works, it works. So don't get too bogged down if you feel like you're not doing it the quote-unquote right way. You'll get a sense of things as you keep practicing. Good luck on your game dev journey, and most importantly, have fun.